Hi everyone. This is Extracting All the Azure Passwords, and I'm Karl Fosaaen. So a little bit of background on myself here, practice director at NetSpy. I've been with the company for about 10 years now. During that time, I've worn a number of different hats, including pen tester, social engineer, password cracker, currently cloud enthusiast. I lead up our cloud pen testing team out of our Portland, Oregon office, along with being a cloud enthusiast who works in a number of different clouds, primarily Azure, but also AWS, GCP, and handful of other different clouds that we end up running into. I'm also a bit of a cloud enthusiast as a private pilot. My wife and I like to spend time flying around the Oregon area in a 79 Piper Warrior, which is kind of a fun plane to fly. Outside of that, I've spent about the last year or so here working on penetration testing Azure for ethical hackers with David Okioti. It's a book that's going to be published on Pact Publishing in October. And it was a fun book to write and contains a lot of information that we're actually going to be talking about today in regards to extracting Azure passwords. You can find any code examples for tools that I work on out of the NetSpy GitHub. I also like to blog on the NetSpy blog, and you can find me on Twitter at @kfosaaen. So today we're going to learn about extracting credentials out of Microsoft Azure. But before we get into that, we should really baseline on what Azure is, just so that everybody's got common terminology to understand and understand how the platform itself works. We'll just go over some basics here real quick. So at its core, Azure is the cloud provider from Microsoft. So it's a lot of Microsoft services that are integrated within the overall Microsoft ecosystem, and everything's being brought up into the cloud. So things that you've traditionally seen on-premise, like virtual machines, applications, anything that hosts an application or interacts with data somehow is now being moved into the cloud. So we're going to talk about a number of those services today during the talk, but here's just a handful of kind of common services that we run into in the Azure cloud. So one thing to keep in mind with the Azure cloud is that at certain role levels, and we'll talk about how roles are applied in an Azure tenant, but at certain role levels, passwords are everywhere. There's clear text passwords that can be pulled out of individual services, and today we're going to talk about different ways that we can pull those out of those services. So to understand an Azure tenant, we need to kind of understand what items are comprising that tenant. So the Azure Active Directory tenant, or Azure AD tenant, is the core of identity for Azure Cloud. So as that core, you have security principals, which you can think of as users, and those users are assigned roles. So the principals themselves can be made up of your more traditional users, Karl at netspy.com, something like that, or guest users, where we could say Karl at gmail.com, where that's an external user to that tenant that's been invited to be a part of that Azure Active Directory tenant. So those are more traditional users, typically assigned to specific profiles and daily use accounts. There's managed identities that can be either system assigned, which means it's tied to a direct resource, or user assigned, meaning it's created within a subscription and can be assigned to multiple different resources if need be. These managed identities are identities that are tied to a specific resource. So let's say a virtual machine or an app services application where that specific resource needs to access something in the Azure tenant and uses that managed identity to access that. There's a number of different ways that we can get authentication for that managed identity, primarily through requesting tokens. But those identities are typically used within the Azure Active Directory tenant to access other items within a subscription, and that's a security principle that could have a role. There are service principals that, not to be confused with security principles, but service principals are typically referred to as application accounts. So you can see things like enterprise applications that may have what are called app registrations that are considered service principals. These both can be assigned roles within the Azure Active Directory tenant, and we can use credentials from these service principals to authenticate to the tenant. So a lot of different types of security principles here. At the core, we just need to understand that a security principal can have a specific role in a tenant, and that role dictates what we're able to access. So at the subscription management group type of level, those roles that are being applied are typically owner, contributor, reader, kind of as the three primary items that we're seeing. Owner being somebody that is able to assign resources, specific applications of roles. So as an owner, I could assign somebody reader rights to a specific resource group or resource or subscription. At contributor, we have rights to modify individual resources that are in the platform. The owner also has these rights as well, and they're able to make changes to any of those resources. The least interesting of these is reader, which is something that we're actually granted quite often during an Azure pen test, where we have read-only access. We're not allowed to make any changes to any resources. We can't assign any rights to any resources to any of the security principals. It's literally just you can read information about these resources. So pretty straightforward on the reader. There are additional kind of special roles that can be applied at multiple different levels here. A lot of these are really service specific or application specific, depending on the needs of the service principal or security principal that needs access to something. Maybe it's log analytics contributor, and that user needs specific access to log analytics resources. That's more of a service application specific role that might be applied here. And these roles can be applied at a number of different levels. So at the highest level, the management group, where there are containers of individual subscriptions that might be under a management group, all the way down to individual resources. So somebody could technically have reader on an individual resource, and it's the only resource in the overall subscription or management group that they have access to. So a number of different ways that we can apply these. One thing to note here is that these roles are at what we would say the subscription level as compared to the Azure Active Directory tenant level. So on the previous slide here, we talked about the Azure AD tenant being the core of the identity. That has a whole set of different roles that are applied at the tenant level versus the individual subscriptions or management groups. For today's talk, we're actually just going to be focusing on, we'll say, subscription level contributor, and we'll talk about that on the next slide here. But we can assume that we, as an attacker, have contributor on the specific subscription that we're working with here. Now, some people will say, yeah, but that's basically admin on the subscription. And in some ways, people are correct in saying that. Contributor does have rights to make modifications to any of the resources that are in that subscription. But for the most part, we're seeing developers, engineers, anybody that's doing anything on a day-to-day basis in the platform having the contributor role for the subscription. So in a way, yeah, you are basically admin. I think it's more on par with local admin on your own workstation or shared local admin across multiple workstations on a traditional Active Directory environment. But with contributor, we do have some power here. And as I mentioned before, we'll use that power to extract credentials out of here. There are other roles that we could talk about today that do have access to some of these either application-specific credentials or individual services that we can extract credentials from. We don't really have time to dive into every single one of these. We'll mention a couple of these as we go throughout here, but just keep in mind that contributor by itself isn't the only credential or role that you might need or have access to that allows you to get access to credentials. There are other options out there as well. So first things first, let's talk about how we manually access credentials. We can go service by service and utilize either the portal, CLI, PowerShell commandlets, anything like that to do one-off collections. So we could go to a storage account like we have in the screenshot here and take a look at the key that's associated with that storage account. That's fine, but as a pen tester, I want to be efficient. I really want to spend more of my time focusing on, exploiting the vulnerabilities and diving deeper into the environment versus just manually going out and getting credentials. So what we want to do is automate this process. And conveniently, that's what we've done with Get-AzPasswords. So Get-AzPasswords is a PowerShell function that's used to automate the collection of any passwords that are stored within the Azure cloud. It's part of the MicroBurst toolset, and it's a tool that I wrote to really just automate that whole process. in the past, we would more passively just gather credentials through configurations that we would go through the portal. There are some active tasks that we'll talk about that the Get-AzPasswords function actually automates for us so that we don't have to manually do these attacks every single time. So it really helps automate this whole process. And what would normally take, we'll say, about an hour to go through an entire subscription and get all of the credentials out service by service, it can do that in a matter of minutes. So very convenient for us from an attacking standpoint, and allows us to audit any of the credentials we have access to. So that can be found on the NetSpy GitHub under the MicroBurst repo, and we'll be talking about it a little bit more today. So the first of the services that we're going to talk about under the Azure umbrella here is Key Vaults. So pretty simply, Key Vaults store keys. It's a service for storing credentials, be it keys, secrets, certificates. We've seen all sorts of different things that get put into Key Vaults as a way to protect that within the Azure infrastructure. Now, there are additional protections that you can apply to the individual keys themselves, and we'll talk about that in the access policies. But for the most part, Key Vaults are really just used to store sensitive information and retrieve it as a specific service principal or security principal in the Azure tenant. So dumping the credentials from the Key Vault service manually, we can just go through the portal or utilize CLI or PowerShell commandlets, anything like that, to query the individual secrets, keys, certificates, anything like that from the Key Vaults themselves. Within the portal, this is really simple. We can see here that we were able to access the super secret password secret, and if we hit the show secret value there, it's a password value, and we'd be able to return that directly in the portal. Like I said, this is not the most convenient way to gather all of these credentials, so we like to automate that with the Get-AzPasswords. But from the portal, it's actually really easy to get these credentials out. That is, if you have rights to read those credentials. So as I mentioned, there are additional policies that you can apply to Key Vaults to restrict the access to the secret data that's being stored within the Key Vault. This is done through something called an access policy, and access policies are tied to individual principals, as we can see here as the select principal. We can select individual security principals that we apply the Key Vault permissions to. So this could be list, get, create, modify, anything like that. And that's per individual type of permissions. So this is key, secret, certificate. We can modify this individually to allow somebody to get and list these specific keys, secrets, and certificates as needed. This is a really handy thing within Azure to limit the scope of who has rights to access the Key Vault keys. However, anyone that has rights to modify, be it contributor or Key Vault contributor permissions on the Key Vault, they would have rights to modify these access policies. So we, as an attacker, if we have contributor level rights on that Key Vault, we are actually able to modify these access policies to give ourselves access. We'll talk about that in a second. There is one additional restriction I want to talk about here, and it does apply to some of the other services, but we don't really need to extend it, is the private endpoint connections. So what you can do with Key Vaults is you can restrict access to the Key Vault to a private endpoint or individual virtual networks or just selected networks that you want to restrict access to the vault for, which is a great control to put in place. It prevents somebody from the internet going and talking to your Key Vault to pull down keys and secrets. If you're utilizing private endpoint connections, that really gives you an extra step ahead against any attackers that get access to a principal that might have rights to read the actual credentials here. Now, from a contributor level attacker's perspective here, we could technically change this from private endpoints over to all networks, but that would be a pretty major state change. And if I'm working in a client environment, I don't want to expose their Key Vault out to the internet and potentially allow somebody to gain access to that. So not something that we would really recommend doing, but from an attacker standpoint, that is something that they might consider. So from a Get-AzPasswords perspective, we're going to utilize the AZ PowerShell modules to automate the whole process of identifying all the key vaults and then gathering all of the key vault keys, secrets, certificates out of that. And for each of the key vaults that are in a subscription, we'll take a look at the current access policy that we talked about on the previous slide here to see if our current user has the ability to get or list the keys, secrets, anything like that out of the key vault. If we don't have access to that, what we'll do is snapshot that access policy, modify it to add our specific user, and then extract everything that we need to extract out of the key vault. Then once we've dumped everything out of there, we'll go ahead and return that access policy back to its original state. Kind of a sneaky trick, but it's actually really handy if we have contributor rights to modify these things, as if we're trying to access keys that we don't have access to, that might actually cause more alerts than just changing the access policy temporarily to give ourselves access to those keys and secrets. So next up, we'll talk about app services. And app services is kind of a larger umbrella for the overall hosting of web applications, APIs, function, logic apps. All of these kind of have their own little elements within them, but overall they kind of work the same under app services. The app services umbrella, everything has configurations for the service itself. These configurations include things like connection strings for connecting to databases, any passwords used to upload code for the app service. So, if you think a traditional IIS web application, moving that up to the cloud, you need to be able to access that app service up in the cloud. In order to do that and upload files, you can either use FTP, there's a web management portal as well. We're able to pull those credentials. We'll see that on the next slide. Additionally, there's access to just the source code itself. Function app files, we're actually finding quite frequently people will hard code credentials into those. Likewise with logic apps, we might be able to extract credentials out of those. And then just the app services configuration service, where we can apply the same configuration across multiple different app services and just maintain that same configuration. That's going to store things like connection strings and potentially have stuff that we can pull out of there. So from a Get-AzPasswords perspective, we're actually just going to be pulling out things from Get Publish Profile here, but doing this manually within the portal, we can see that there's a link within the App Services application to get a published profile. And while I've redacted all of the passwords that are in here, we can see in the text file here that we've got usernames and passwords for web deployments, for FTP deployments, and database connection strings that might be in there. This is just a nice handy one-off if you happen to get access to the portal and want to quickly get credentials for app services. The getting published profile is actually pretty straightforward and a quick way to get a couple of credentials there. So to automate that, we'll talk about how we're going to pull those out with Get-AzPasswords. Did mention the FTP and web management credentials. One thing I did want to note about this is that if you browse to the actual /basic auth endpoint for the SCM, which is the Kudu environment for managing these app services environments, you can just use the username and password that was pulled out from the settings here on the previous page. This is really handy for persistence, as you can keep those credentials, and I don't frequently see people rolling those credentials over. So if we get access to those settings and those credentials, we could potentially maintain access through this Kudu environment through this basic auth endpoint here on the SCM. So you can see netspy.scm, azurewebsites.net. And if we authenticate against that basic auth endpoint, that allows us to maintain access to Kudu, which is, there's a web shell there, there's file browsing, there's all sorts of different ways that we can persist in that app services environment. Quick thanks to MC Omai, who does Storm Spotter. He's the one who initially pointed me to this kind of interesting bypass here. So one thing to note, we talked about managed identities and how those are used in Azure Active Directory tenant. App services are frequently configured with managed identities, and those managed identities are used to allow access to key vaults. So we talked about key vault access policies. these managed identities would be added to the access policy for the Key Vault in order to read keys, secrets, certificates, anything that you might need within an Azure App Services application. So from an attacker's perspective, if we're able to get control over an app services application, we can generate a token for that managed identity and have that scope to the management APIs and the Key Vault APIs, and use that to go ahead and take the REST APIs to pull out all of the Key Vault contents. We do have a couple of automation scripts within MicroBurst to automate that whole process with the Get-AZ Key Vault keys REST and secrets REST, so that you can pull out all of those Key Vault contents that we talked about in the previous set of slides here. So something to keep in mind if you get access to a managed identity in App Services. So now with that detour out of the way here, let's talk about how we automate that. Really, it's just getting each of the AZ web apps or app services apps and piping that into getting the publish profile. This is really straightforward. It's just a couple of lines of PowerShell, and then we'll parse the JSON output that comes back with those publishing profiles to get those credentials out for the output. Next up, we've got automation accounts, and this is one of my favorite parts of the overall Get-AzPasswords presentation here. I'm a big fan of automation accounts. There's a lot of different things that we can do with these, and a lot of interesting things that end up getting stored here. So from a service perspective, automation accounts are meant to run serverless code up in Azure to automate your day-to-day tasks. So management of systems, management of your Active Directory tenant, just really managing all of the things that you need to manage without having that running on somebody's desktop. You've got your serverless environment where you could schedule these runbook code books to just run whenever you need them. So if you need to shut down all of the virtual machines, during a certain window, you can automate that with automation accounts. It's super convenient. Runbook code's typically in Python or PowerShell, and it's just a nice, easy, lightweight scripting environment to run serverless code. So the platform itself stores credentials for the automation accounts in credential variables. I can also accidentally have those included in the source code itself for the runbooks. There's also run as accounts that can be used within the runbooks. So you can think of that almost like a managed identity. Automation accounts are moving towards using managed identities. It's kind of an in-progress thing. I think it's still technically in preview, but that's going to eventually replace these run as accounts, and we'll talk about how we can use these run as accounts. There is something important to note here with the run as accounts. If you're going to use those in an automation account, by default, those are set as a contributor on the subscription. So if we're able to extract the credentials for that run as account, we'll have contributor rights in that subscription. But typically you need contributor in order to extract those anyways. So we'll talk about that a little bit more in a second here. Additionally, you can also access key vaults from automation accounts, kind of like how we talked about the app services accessing key vaults with tokens. There's similar things that we can do with either run as accounts or additional credentials that are supplied to the automation account. The bottom line is typically we see key vaults being accessed from automation accounts to pull in secret data. Let's say there's a shared password or a key that's being shared across things that need to be automated. That might need to be pulled from a key vault first into the automation account runbook, and we might be able to abuse that runbook to then get access to the key. So for the clear text credentials themselves that get stored in a runbook, this is really easy to audit. If you've got portal access and just use the view within the portal here, we can view the source code for the runbook and potentially pull out clear text credentials. It's really simple. You can read the code and they're right there. It happens more often than you'd like to admit, but something to look out for there. Additionally, if we want to pull out the platform level passwords or any of the run as credentials, we need to run a custom runbook to extract those. So the runbook being PowerShell code here that we're looking at, and we won't go line by line here, but essentially what we're doing is we're casting the available credentials. In this case, there's a test credential. We can also see in the sidebar, there's a Karl credential stored there. But what we can do is cast that credential out to a variable and write that out in the output. Additionally, we can take the run as certificate by getting the individual certificate itself from the environment and then casting that out to a base 64 string, which we could then copy out and save elsewhere. So in order to do that, we would use what's called the test pane. So we can see here just above the code, there's a little box that says test pane, and this is the view that we're going to look at here. So in the test pane, you can run your automation account runbook, and that will output any of those stored credentials, output that run as certificate here that we can copy off of here. And this does not get logged as the jobs within the automation account. Now you might be looking at this and going, ooh, yeah, there's clear text credentials that are being returned back to the screen. I hope these aren't being logged anywhere. If you're running this as an actual job, yes, that would happen. But if you're running this in the test pane here, this never ends up in any of the logs. All that you see in the logs is that the runbook was saved and that the test pane job was run, but the actual output never comes back there. So it is kind of a stealthier way to get these credentials manually, but it's also not the most, it's a little slow to go through all of this. I've spent more time than I'd like to admit waiting for automation runbooks to complete. So, automating this through Get-AzPasswords is much faster. So speaking of, when we do that, we want to encrypt all of that output. So when we're potentially outputting clear text credentials that might, contain actual credential data here, we don't want somebody with reader level access to be able to read the output of these jobs and potentially get access to data that they shouldn't have access to. So we can see on the left here the before and on the right the after of what our encryption method looks like. So what we utilize is a certificate that gets uploaded with the runbook, and we keep the private key on the Get-AzPassword side so that we're able to decrypt everything on our end here. But we'll encrypt all of that output in that output pane here and then clean up after ourselves after everything's done so that nobody can actually decrypt that output that is put out into the jobs output here. This is just a much cleaner way of getting output back from the automation account itself, and it protects everybody from accidentally exposing passwords. So something to kind of keep in mind as we're utilizing automation accounts and getting credentials out of there. So like we talked about with the app services and getting access to key vaults, there were some issues with run as accounts being able to read key vaults and some permissions related items that Microsoft addressed with the CVE back in 2019. But we put together a runbook automation script called Get-AZ Key Vaults Automation within MicroBurst to help automate that whole process of extracting credentials from a key vault utilizing automation account runbooks. That could be a whole nother talk in terms of kind of how all of that gets orchestrated within the runbook itself, but just something to kind of keep in mind if you get access to an automation account and want to access an attached key vault, there are tools in MicroBurst that you might be able to use there to automate that process. So getting all of these credentials out with Get-AzPasswords. We've talked about all of this kind of as a whole, but for each automation account, we basically list out any available credentials, run as accounts, and we're going to upload a malicious runbook. I say it's malicious, but we're the ones running it. It's just going to be extracting credentials here. We do randomly name these, so if you happen to find evidence of a randomly named runbook in your subscription, something like 15 characters long, upper and lowercase letters, that may indicate Get-AzPasswords was run in that automation account. But once we upload and run that runbook, that will extract those credentials, encrypt everything on the fly, and decrypt those credentials client side once we pull the output from the automation account job. Then we'll go ahead and clean up those automation runbooks after we've completed everything. One important thing to note here, if you're going to run Get-AzPasswords, is do not use Control-C while that function is running, particularly during the automation account phase. If you Control-C while an automation account runbook is still running, that will leave that resident randomly named runbook up in the automation account. And we don't want to leave anything behind, and that may potentially just leave behind indicators of compromise, anything like that. So you want to make sure that you clean up any kind of orphaned runbooks that end up there if you Control C while the function's running for Get-AzPasswords. So for storage accounts are pretty straightforward. They store things. It's file storage in the Azure cloud. You can think of it as kind of like AWS S3 for those that are a little bit more well-versed in AWS, but for the Azure platform. Now, unlike AWS S3, the storage accounts in Azure also have different file storage types. So we have blob, table, queue, file. All of those are different ways of storing either data or just files, flat files, anything like that. We're really going to be focusing on keys that can be used to access any of those different types of storage items here. But in general, storage accounts store files. You can think of it that way. And in order to access these, we have keys. We took a look at this earlier at the very beginning of how you would be able to extract keys out of a storage account on the very first couple of slides here, talking about getting the keys for individual storage accounts from the portal. Additionally, you could go through available files in things like file services or blob storage where there might be clear text credentials in a configuration file, anything like that. That's not really an easy thing to automate, so we don't automate pulling down credential files or anything like that with Get-AzPasswords, but as a pen tester, you might want to keep in mind reviewing individual files once you get to a point of contributor or storage account contributor in an Azure subscription. We do frequently find configuration files that are hanging out in storage accounts, which lead to other credentials. But for our purposes here, we're really going to focus on getting these storage account keys. These can be used with the Storage Account Explorer. There's a number of different ways that we can use these keys to get access to the actual storage accounts themselves and view some of those files and persist potentially in that storage account environment. One of these ways is with Cloud Shell files. So as I mentioned, we can get access to those keys, access the associated file shares for any Cloud Shell file shares. Typically, these are going to start with the letter CS and then some random letters and numbers generated after that. These are file shares that are created to run your Cloud Shell environment. So if you've ever used the Azure portal before, and more specifically used the Cloud Shell environment underneath that, you would have seen when you created the Cloud Shell environment an option to either select an existing storage account or create a new storage account. Typically, when you create the new storage account, it creates that CS prefixed file share storage account within your subscription to store all of these. What I have seen in the past is that depending on the environment, multiple people might share the same Cloud Shell storage for each of their different Cloud Shells. This is potentially really dangerous, as anyone who has contributor rights on that storage account has rights to modify those file systems. So if I, as a user, am using Cloud Shell that's going to store an IMG file, which is an ext2 file system, up in a Cloud Console folder up in the file shares. What we can do as an attacker is pull that IMG file down, mount that on a Linux system, and either review any files. So let's say I store configuration scripts up in my Cloud Shell environment that have credentials in them. An attacker could potentially get access to those. Additionally, you can modify any of these startup files for things like Bash or PowerShell to automatically run commands when somebody logs into Cloud Shell. So as an attacker, we download the file, mount the file system, modify the startup files to say add our user as an owner on a subscription, or do some other types of malicious commands here. We re-upload that IMG file up to the file share, and the next time that victim user opens up their Cloud Shell environment, that executes those commands in that victim's Cloud Shell. This can be potentially pretty dangerous. If I'm able to poison the Cloud Shell account of a global administrator account, that would be an easy way for me to escalate privileges. So we detailed all of this in a NetSpy blog here that I've linked down at the bottom, but definitely something to keep in mind. We typically just recommend don't use Cloud Shell. If you're going to use Cloud Shell, make sure you're locking down those file shares to limit any potential exposure there. So dumping those storage accounts is really, really simple. We just get a list of the storage accounts, and then for each storage account, we get the storage account key. I could probably cut this down to like a 2-liner, maybe, in PowerShell. You could maybe even just do a 1-liner of get that and pipeline it into the get storage account key. But really, really simple, super easy to automate, and it's really easy for us from a persistence perspective. Next up, we've got Azure Container Registries. So for those that are not familiar with Azure Container Registries, or ACRs, as I'm going to refer to them going forward here, they are a repository for any container images that you might want to use either in Azure services like container instances or Azure Kubernetes or AKS, which we'll talk about next. But it's a service for storing all of these images for any of those services, or potentially publicly exposing Azure registries so that other people can get access to images, maybe intentionally. You want to have a Docker image available for somebody to use. That's what that service is for. So the passwords themselves can either be found in container images. What we frequently see is service principal credentials, like we talked about way back at the beginning, might be stored in these container images themselves. If you've got a Kubernetes cluster and don't want to deal with pulling secrets down into these individual containers as they get spun up, it may just be easier to bake in those credentials into the container images. This is not a good practice, but we frequently see this happening. So as an attacker, we frequently pull down those container images and extract credentials out of them. Really only requires reader level credentials in that Azure subscription to pull those images down, but we'll talk about that in the next slide here. Additionally, there's container registry admin credentials that can be exported for persistence. It's not a guarantee that those will be in the subscription, but we can see here in the portal that these are enabled for the NetSpy container registry, which is now since gone. But for demo purposes, we created one here that we had an admin user enabled for. Additionally, talked about the container images and how those are quite often storing credentials in the images themselves. From an attacker standpoint, we just pull the images down, run the images with whatever their base shell is, do a print env, see what their environmental variables are, see what local files are available there. We'll frequently find application configuration files, web.config files, anything like that frequently store clear text credentials. So definitely something to look out for if you're pen testing Azure Container Registries. From a Get-AzPasswords perspective, we really just care about getting those admin credentials that we showed at the bottom of this slide right here. So that just gets a list of all of the container registries and then pulls any available admin credentials for the container registry itself. Much like storage accounts, this is really, really simple. Potentially could be a 1-liner if you really wanted to cut the code down a little bit, but a very simple way to potentially get credentials out of the platform once you're at contributor level. So as a service that is supported by ACRs, Azure Kubernetes service is just Kubernetes clusters in the cloud. So if you want to run Kubernetes up in Azure, Azure Kubernetes is probably your best bet. There are multiple different ways that you could potentially do that with virtual machines and other things, but we don't need to get into that here. What I'm frequently seeing in Azure environments is the AKS service being used to run clusters. So the passwords themselves, frequently found in the cluster VMs themselves. We'll talk about how service principal credentials and managed identities are utilized there. Additionally, there's admin credentials that can be exported for persistence for managing the cluster itself. So these are the kube-config file credentials that we can export to use locally to manage the Kubernetes cluster, potentially remotely, depending on how things are configured. For the virtual machines themselves, the service principals or managed identity tokens, you have to choose one or the other when you set up that AKS cluster. And the service principal credentials end up getting stored in clear text in an azure.json file. And managed identity tokens, we have to generate those every time, but we'll talk about how we do that in a minute. So if we have portal access for something and want to just quick generate the kube-config files via Cloud Shell, you can just use the AZ CLI within Cloud Shell to add the AKS cluster credentials into your current system. One thing to look out for if you do get access to Cloud Shell files, like we talked about earlier with storage accounts, is looking out for kubeconfig files in those IMG files. Those can get stored there, and they can last for a while, so you might be able to pull live Kubernetes credentials out of those Cloud Shell files. Super convenient from an attacker standpoint. But for more of a manual export here, if we add those Kubernetes credentials here and then just cat out the kubeconfig file here, we can just copy that out of Cloud Shell and grab that at that time. You can also use --admin to specify as a cluster admin versus a regular cluster user. Not a huge difference. There are minor differences there. I'd recommend using --admin if you're going to go this route, but besides the point. We automate this with Get-AzPasswords by grabbing both the regular admin and the regular user credentials as part of this whole process. But in general, we get a list of all of the clusters. We generate a token to use with the REST APIs. This is the one spot where, excuse me, where we typically differ a little bit from the standard PowerShell commandlets. Here, we're going to use some of the REST APIs, which is just a little bit different than kind of the standard tools that we're going to use in Get-AzPasswords. But using that token, we're going to pull down the different cluster admin and cluster user credentials in the kubeconfig format. If the cluster itself is set up with a service principal, we're going to invoke the azvmss VM run command. I know it's a mouthful there. Basically, it's a virtual machine scale set that's supporting that cluster, and that's able to expand and contract and spin up different node pools, anything like that for AKS. What we want to do with that virtual machine scale set is cat out that azure.json file that stores that service principal credential. Alternatively, if it's a managed identity, instead of catting out that file, we'll just make a request out to the metadata service and pull back that metadata token and get access to any tokens that we need there for the managed identity. So for the demo here, I'm going to use a video that I recorded from a sample environment here, but this is running Get-AzPasswords. You can see here at the top that I've imported the MicroBurst module. We're going to run Get-AzPasswords with modify policies as yes and export certificates as yes, meaning we're going to export any of the certificates that are available in physical format into an individual file. So we can see we wrote out democert.pfx. Additionally, for any access policies, we will modify those in line here to give ourselves access to any of the key vaults, keys, secrets, certificates, anything like that as we need them. So I do have this pretty sped up here. We have it at 10x speed here, but I'd say in general for an average subscription, usually just takes a handful, and say maybe 5 minutes at the most, to export all of those credentials. So we can see here there was a PFX file that was created and an authenticate as PS1 file here, which we can potentially use to authenticate as a run as account. And we can see all of these credentials that we outputted to out grid view. This is a handy way to export all of these credentials. I'd also recommend just using export CSV instead to have everything out to a CSV. You could just copy everything out of here instead, and that's a little bit different, but we can see in the output here things like AKS service principal here. We can see the client secret that was attached to that service principal, along with access keys, Cosmos DB, which didn't even talk about, storage accounts, all sorts of different stuff that gets output there. So real quick here, we'll just talk about a privilege escalation that we were able to identify in Azure utilizing the Get-AzPasswords function here. But basically what we were able to do was use Get-AzPasswords to get the run as account for an automation account via the log analytics contributor role. Previously, the log analytics contributor role allowed star permissions on all automation accounts, which allowed us to then export any automation account run as certificates and go through that process of getting the run as account, which is a full contributor on the subscription by default, and having that run as account, we're then able to escalate our privileges. It's a mild privilege escalation. Log Analytics contributor did have a fair number of rights in that role itself, and escalating up to contributor was just a small jump up to full contributor, but it was technically a privilege escalation. Microsoft recently addressed this in August. They actually removed the automation account star permissions. They temporarily had a disclaimer here saying that it did allow for the privilege escalation here, but they recently cleaned that up. So quick thanks here for our MicroBurst contributors here, Jake, Josh, Thomas. They've all helped contribute to MicroBurst and add things to the platform here. The slide design assistance here from Sophia at NetSpy. She was responsible for the MicroBurst with the knife there for attacking the cloud. And mentioned MCOMI here already for the kind of basic auth login hack. So thanks for that. And our last slide here, just a couple of different links to include here for NetSpy GitHub, the blog, and some of the specific blogs that we talked about today. So you can find me on Twitter at @KFosaaen, and feel free to reach out with any questions. Let me know if there was anything I can help clarify here. Otherwise, thanks.